Hello, and welcome back to Cognitive Psychology. Thank you all for your patience and good questions that you asked about quizzes, chapter notes, and everything like that. Still adjusting things left and right. Unfortunately, my chapter 3 recording, something went wrong with the actual, I don't know. I have been Googling things for a while, just trying to figure out why the file itself is corrupted. But I'm figuring that out, and I will be re-recording that and posting it. Thankfully, the lecture slides were posted. I will also be posting the lecture slides from this lecture on Thursday. I'll also be posting the discussion for Chapter 4 today, and that'll be due next week. And I will be posting the quiz for Chapter 4 on Thursday. Just to let everyone know, our first exam is coming up, and that will be a similar format to the quiz, although that is going to require the Respondus lockdown browser. I'll talk about the notes system that I'm going to allow you to use for that first exam, but beyond that, we'll go into more detail on Thursday. Okay, so attention is often a word that we use to grab people's attention, to pull someone's sight line from one area to another, to get people to listen up. Well, in the area of cognitive psychology, we talk about attention in regards to how we actually manage our perception and how information is deemed to be what in cognitive psychology is termed as salient or important. And so some of the stuff I'm going to talk about today is going to be about the history of attention and how it was studied. And we'll talk a little bit about how different perspectives regarding attention influenced how people studied it. So, some things to think about for this chapter. First off, how does attention work? A lot of what this chapter addresses is in regard to a lot of colloquial terminology we use in regarding to attention, splitting attention, moving attention, focus, losing focus, paying attention. And one of the questions that I want you to think about is it possible to focus attention on just one thing, even when lots of other things are going on at the same time? So that idea of blocking out information is a really important area of study in attention and cognitive psychology. Also, under what conditions can we pay attention to more than one thing at a time? What circumstances do you find yourself in which you have to rapidly switch between different things, paying attention to different objects, different stimuli? What does attention research tell us about the effect of talking on cell phones while driving a car? And this is a very specific example in regards to distraction and what sorts of things we can actually accomplish based on the salience of our environment. And finally, is it true that we are not paying attention to a large fraction of things happening in our environment? Spoiler alert, the answer to that is yes, but not as hard a yes as you might think. It's not that we block out everything, it's a matter of what things actually make it to our short-term working memory. So, attention is the ability to focus on specific stimuli or locations in our environment. And for today, I'm going to focus on selective, but there are two different types of attention that we'll focus on primarily in the chapter in this book. First off is selective, so that's attending to one thing while ignoring others, so that idea of specific selective focus. And then divided, paying attention to more than one thing at a time. People sometimes refer to this as split. It's also referred to as attention switching, and basically the idea of being able to move from one object to another rapidly in a way that almost seems as if we're paying attention to multiple things at one time. But for today, we're going to focus on selective. Now, selective attention. When this was first being studied, there were a lot of studies that focused on selective attention as basically our ability to focus on a message and ignore other messages. If you remember, I'm going to talk a little bit about the dichotic listening task and how that experiment worked to show us and to demonstrate what sorts of things we can do with our attention. Selective attention is also a perspective that espouses the idea that we don't attend to a large fraction of the information in our environment. While I might have my eyes open and my ears are open all the time, there's a lot of auditory and visual information that is constantly barraging my senses, and we're not paying attention to all of it at once. And so selective attention tries to address this idea that we can focus that attention and we're not just receiving information incessantly. The way that we do this is through what a lot of researchers refer to as a filter. Now, specifically, earlier theories will talk about a filter, but as we go later on, that filter gets switched into a dictionary and so on and so forth. So think about it in terms of some sort of threshold that is being met in regards to whatever stimuli is in the environment. So, the dichotic listening task, this is kind of one of the first attention studies that was done earlier on. And so just as a reminder for this, the dichotic listening task works similarly to a participant puts a pair of headphones on, a message is presented in one ear, and a different message is presented in another ear. I am asked by the experimenter to shadow the message coming out of this ear. In order to do that, I basically say the message out loud while both messages are being played. So the question that researchers were asking is, can we completely filter out the message in the unattended ear and only attend to the shadowed message? Basically, can we completely drown this out and not pay attention to any information that's coming in our left ear? So here's an example. Billy, he's hearing the message, the meaning of life is, and the yellow dog chased in another ear. He's been asked to shadow his left ear, and so he's saying the yellow dog chased. So the results confirmed a lot of these ideas of selective attention and our ability to control what we're listening to, but it also revealed that there's information that's still getting through. So regardless of whether or not we were asked to shadow in this ear, we still got some information coming in from this ear. For one, we knew that there was a message there, so it didn't just sound like white noise. Also, participants knew the gender of the speaker, so basically the pitch of their voice. Was it higher, was it lower? The problem with that is that selective attention is not being so specific. The unattended ear, the information going into the unattended ear is being processed at some level. We don't know what level, but it's being processed at some level. And this is what's referred to as the cocktail party effect, and I'll explain this a little bit more, but the idea that if you're having a conversation with someone at a party or in a loud concert, a bar, just basically a large group of people, then there is still an opportunity for us to hear other conversations around us, even though we are trying to selectively focus on a single line of stimuli, so that specifically being the person that you're speaking to. And we can hear strange changes that occur around us. And in the cocktail party effect, we talk specifically about hearing our names. Now, the question is, because this cocktail party effect occurs where I can start to attend to information that I'm not selectively focusing on, the question becomes, where does the filter occur? So does it occur early on in processing and then cut off any information from getting into short-term memory? Or is it occurring later on in processing? Is there more information getting through than what earlier theorists might have thought? And we're going to talk about these three different models. The early selection model, which was espoused by Broadbent. The intermediate selection model, which was espoused by Dr. Ann Treisman and her attenuation theory. And then a late selection model by McKay. And the late and the intermediate models are much closer in theory than the early selection model is to the other two. So we'll talk about those three right now. So Broadbent's filter model focuses on this idea that a message comes in, it goes through sensory memory, so this can be kind of like a perceptual buffer where information is being stored very temporarily, so a very brief period of time. That information moves to a filter, a cognitive filter, that deems whether or not the information in sensory memory is important. And if it's important, it passes through the filter to the detector. And that detector is what establishes whether or not this information needs to be held in memory or kind of just used very briefly and then forgotten. So sensory memory holds all this incoming information for just the tiniest fraction of a second, and then it transfers that information to the filter. This filter identifies intended messages based on physical characteristics and what's important in the message. What am I looking for? Do I know the physical characteristics of the person I'm talking to? Do I know what sort of pitch I'm listening to? If volume is much higher, that might be an indication of some sort of emergency. So this filter captures a lot of different contextual pieces of information. And based on those physical characteristics, whatever attended message is passed on to the next stage. The detector is the part of this model that actually processes the information. So the baseline physical contextual information, pitch, tone, amplitude, volume, all these sorts of things are being processed by the filter. The detector is what actually establishes the actual content of whatever stimuli is being presented. And then that can be moved to short-term memory and then either moved further on to long-term memory or used immediately in working memory. And we'll talk more about those memory mechanisms later on in the semester. But for now, just think about that in terms of that sort of working table. You've moved the information to this place, and you have to decide whether or not you are going to finish cooking or finish making whatever you're going to make right there and then and there, or are you going to wrap it up and store it for later use? Now, the problems with Broadbent's model and this idea of a very specific filter or threshold is that the cocktail party phenomenon exists. The fact that information is still getting through regardless of whether or not that contextual physical characteristic is important. And so participants were shown also that they were able to shadow meaningful messages that switch from one ear to the other. And so Gray and Wedderburn actually did an experiment in which phrases like "Dear Aunt Jane" were split between two ears. So that in this ear I heard "Dear 7 Jane," and in this ear I heard 6 Aunt 8. And when they asked participants afterwards what messages were being presented to them, they actually synthesized "Dear Aunt Jane," because even though they were told not to attend to this ear, that information was still getting through. So this very specific filter model doesn't really suss out as far as how attention actually works. Now, what Treisman proposed with her attenuation theory was the idea that a message can be separated from so your attended message can be separated from your unattended message early on in the information processing system, but even though that separation can still occur earlier on, the really important part is the selection that occurs later. So rather than just a filter blocking any information that's not deemed to be salient, all of that information is getting through, and the attenuator acts as kind of a volume dial for whether or not, if something is attended, the volume is higher. If something is not attended, it's lower. It's not literal volume, but the idea, you can think about it in terms of action potentials. I need a stronger boost from my attended message and a weaker boost from my unattended message, but the information is still getting through. So that attenuator analyzes the incoming message in terms of physical characteristics, language, meaning, a lot a little bit more information than Broadbent's filter, and then based on that information, it moves through the attenuator and is established as an attended message, and it's let through at full strength. If it's unattended, then it's still let through, but it's at a weaker strength. The dictionary unit is kind of the contextual component to the attenuation theory. The idea of the dictionary unit is this is the thing that holds our experience, our knowledge of circumstance, and it allows us to actually establish the thresholds that allow for an attended message to be stored to memory. So even though I'm still hearing, so even though both of these messages are getting through the attenuator, the much stronger attended message probably contains words that are common or important and have low thresholds, whereas the unattended message usually holds uncommon words that have high thresholds. And this threshold can change based on the context of a conversation or whatever stimuli is being presented. So in this example, words like own have very low thresholds. Words like rutabaga have very high thresholds, so it's harder for them to get through. And words like boat kind of fit somewhere in between. Now, McKay added on a little bit to that and started looking at selections of stimuli for final processing and whether or not that occurs after information has been analyzed for meaning. So is adding on to that important component of the attenuator, but also including that quality of information that occurs when we're attending to a message. And so what McKay did to study this and establish whether or not there are kind of these post selection processes going on even past these dictionary units was to present the message or present ambiguous messages to participants that they would hear. They were throwing stones at the bank. In the unattended ear, however, some participants heard the word river and some participants heard the word money. So what McKay found was that when they were tested later on as to what they remembered, they tended toward choosing the unambiguous sentence that was the closest in meaning to the word in their unattended ear. So if they heard the word river, they were more likely to say that they threw stones toward the side of the river yesterday, as opposed to if they heard bank, they would say they threw stones at the Savings and Loan Association yesterday. And so basically this idea is that in the unattended ear, there was still some biasing component to that. And so there was this small kernel of unattended information was influencing that post-dictionary unit attribution to memory. So, and the weirdest thing was that participants were unaware of the presentation of the biasing words. So because they were having to focus on the ambiguous sentences, what their perception was doing, their brain was accomplishing, was it was synthesizing this information and creating meaning for these ambiguous phrases by using this unattended information. You can kind of think about it in terms of if you see an ambiguous figure far off in the distance, you might listen for a moment to see whether or not it's your friend yelling at you or if it's a bear. And so this idea of attention as this resource and our ability to actually process information became very important, so important that we started looking at this idea of the load theory of attention. And I'll show that graphic in just a moment. I kind of put them together for my own reference. But Lavie, very recently, and a lot of attention research is being done right now that is kind of struggling with this idea of load. And the load theory of attention espouses that we have processing capacity and perceptual load. Basically, processing capacity is how much information we can actually process at a time. So how much can our sensory memory hold? How much can our short-term memory hold? Perceptual load is the actual difficulty of a given task or the complexity of a stimulus. So something that's high load is a more difficult task using higher amounts of processing capacity, and a low load or easy task uses lower amounts of processing capacity. The examples here, thinking about it in terms of an actual pool being filled up, the example on the left, we have a lot of remaining perceptual capacity, whereas on the right, it's a high load task and there's no perceptual capacity remaining. The figure on the right shows kind of a high perceptual load versus low perceptual load circumstance in which a participant in the top, who's in a high load circumstance, might find themselves retaining a lot of target information, so that important information indicated by the red, but they're not going to be able to remember all of it because there's still a lot more information there than in the low perceptual load. However, in a low perceptual load situation, participants might end up remembering distractors or non-important information. So basically, there's this kind of trade-off in terms of how complicated do you make a stimulus? Do you make it very high load so that the participants get the most information out of that material, or you make it low load and they're more likely to be distracted and find other things to pay attention to? So that's it for today's video. I'm going to be posting some activities regarding the Stroop task, and I'll talk a little bit more about that on Thursday, and we'll talk more about divided attention and the myth of multitasking. If you have any questions, concerns, comments, please let me know via email. And thank you for your time, and hope you have a great rest of your Tuesday.